Welcome everyone to the Green Chemistry and Commerce Council webinar entitled 5 Things You Can Do to Select Safer Chemicals for Your Company's Product Formulations. My name is Sally Edwards. I'm with the GC3 and we'll be starting in just a couple of minutes. Again, I want to welcome you all to our Green Chemistry and Commerce Council webinar entitled 5 Things You Can Do to Select Safer Chemicals for Your Company's Product Formulations. My name is Sally Edwards. I'm with the Green Chemistry and Commerce Council and I will be moderating this webinar. So let's go ahead and get started. I want to start by giving you some background about the Green Chemistry and Commerce Council. So the GC3 is a multi-stakeholder collaborative that drives the commercial adoption of green chemistry by catalyzing and guiding action across all industries, sectors, and supply chains. And I really want to especially welcome those who are new to the GC3 who are on this call. Our vision is a world where green chemistry is standard practice throughout the value chain. And the mission of the Green Chemistry and Commerce Council is to drive the commercial adoption of green chemistry by catalyzing and guiding action across all industries, sectors, and supply chains. We now have more than 130 members, and they represent many different industry sectors and the value chain. We have many chemical manufacturers, we have formulators, we have brands, we have many retailers, as well as service providers and others. So we really have a wide range of companies that participate in this organization, which really allows for a lot of collaboration and networking that I think our members find very valuable. We're co-sponsoring our webinar today with the Interstate Chemicals Clearinghouse, and we're really delighted to have the IC2 as our co-sponsor. The IC2, for those of you that don't know about this organization, it's an association of state and local governments that promote a clean environment, healthy communities, and a vital economy through the development and use of safer chemicals and products. The goals of the IC2 are to really work at avoiding duplication and enhance efficiency and effectiveness of agency initiatives on chemicals through collaboration and coordination, to build government capacity to identify and promote safer chemicals and products, and to ensure that agencies, businesses, and the public have ready access to high quality and authoritative chemicals data, information, and assessment methods. And you see here the homepage for the IC2. And one of the things to note is the IC2 really provides a range of useful information to support the use of safer chemicals. And one of the ways it does this is through its databases. It keeps a U.S. state chemical policy database, a database of lists that states have developed of priority chemicals, and it also has a database of publicly available alternatives assessments. So all of these are really useful tools toward safer chemicals. So I want to, again, thank the IC2 for co-sponsoring this webinar with the GC3. So ground rules for this call are that due to the number of participants in the webinar, all lines will be muted. If you have a question or comment, please type it in the questions box you'll see in the control panel, and we'll answer questions at the end of the presentation. I encourage you to ask questions. I'm hopeful that we'll have about 10 or 15 minutes at the end. So please send your questions. I will be moderating those. And now I want to turn to today's speaker. I'm really delighted to have Joe Rinkovich, who is president of Cyvera. And Joe will tell you a bit about Cyvera. Cyvera has since 2008 worked with leading consumer product brands to advance chemicals management and safer chemistry. Joe leads product development and customer relationships for Cyvera, and he draws on over 20 years of professional experience in the industry. Joe's led successful startups and consulted with senior executives about how their business can generate lasting value, integrating environmental and sustainability strategies in all aspects of a company's enterprise. And from this work, Joe's really learned how important it is to empower the professionals across an organization with reliable, cost-effective resources to make proactive decisions about product development, supplier relationships, and product lifecycle development. So I'm really delighted that Joe will be speaking with us. So Joe, you can take the reins.
Thanks, Sally. Hello, everyone. Thanks so much for making time for the webinar today. As Sally said, I'm Joe Rinkovich, President of Cyvera, and before getting into the presentation, just a few more words about the work we do here at Cyvera. We're a team of board-certified toxicologists, software engineers, client success specialists, and data management experts. And as Sally said, for over 10 years, we've worked with the world's most recognized brands and their global networks of manufacturers, raw material suppliers, and chemical suppliers who are, as you all know, worldwide in all time zones, all countries in many cases. We offer a web-based software platform called Cyvera Lens and a range of supporting services for these companies and their work. Our goal is our customers' goal, to make more accessible and affordable the work of chemicals screening, chemicals assessment and scoring, and the selection of safer alternatives for all participants in the consumer products supply chain. My colleagues and I at Cyvera are grateful to GC3 and co-sponsor Interstate Chemicals Clearinghouse for the chance to present to you all today. It's a great large group that we have. Looking forward to questions and answers at the end. I'm going to take about 35 minutes or so to get through some slides, and then we can kick into some interaction. Let's get started. So the title, 5 things you can do to select safer chemicals for your company's product formulations. It's of course a very complex topic, and I have a feeling some of you signed up for this webinar to see what the 5 things are, but also see what specific steps you might be able to take and what resonates with the work you're already doing in this area. I want to spend just a few minutes talking about how chemical screening has changed and is continuing to change, get into these 5 specific steps you can take, and then leave some time, of course, for questions and discussion. But the goal here is to understand through some examples and some stories as part of my presentation, ways you can identify and select safer chemicals for your products and processes and work with your supplier relationships to get that work done, because that's really where it's key. So as a thesis statement, chemical and formulation decisions occur upstream, while brands and retailers incur the quality and reputational costs or challenges or achievement downstream. And traditionally, the model has been testing of finished products and representations from suppliers about compliance. But as you all know, the reason you're on this call and engaged with GC3 is there's much more to that these days for chemical screening and understanding chemicals and protecting the brand and reducing business risk. This idea of chemicals management for consumer products has shifted dramatically over the last several years. There are now increased expectations from a broad group of stakeholders, NGOs, consumers, retailers, government, participants in the supply chain that are driving this change. All retailers, brands, and their supplier networks really need to think about the current processes they have in place and update in critical ways to respond to these changes. Global brands and their suppliers need scalable, reliable, and most importantly, cost-effective solutions to meet these new requirements. I think a lot of people hear chemical screening and chemical assessment and alternatives assessment and think time-consuming, very expensive steps. And one of our goals at Cyvera, and we've achieved that in many ways already, is to make the work more cost-effective, faster, and easier to implement, even when you're dealing with suppliers way upstream, confidential ingredient information, all of those challenges. So here's a map or a ladder of how we have observed and noted chemicals management to have changed over the years, and hopefully this resonates with you. Very interested in feedback from anyone on tweaks to this model. Basic chemical compliance way back in the day, before most of us were probably engaged in all of this, just trying to avoid bumping up against regulations. That was the initial approach. Over the last decade plus, restricted substance lists, RSLs, and manufacturing restricted substance lists for the supply chain have gotten some momentum and have been implemented in a variety of categories and in a variety of ways at the company level, at the industry level, for markets, et cetera. Also gathering some momentum over the last 10 years or so is certification schemes looking at third parties involved in screening chemicals against lists, doing testing of formulations or materials, and validating a particular claim and putting a certificate associated with that formulation or that product, either at the material or the finished product level. Lots of momentum there. Then qualitative hazard assessment is a term we're using to describe some of the frameworks that are out there for evaluating hazard in a categorization perspective. So if you look at systems that we're involved in, the Green Screen for Safer Alternatives is a great example of a qualitative hazard assessment where you bucket chemicals into chemicals of concern, acceptable chemicals but need improvement, and preferred chemicals. US EPA's Safer Choice program is another good example of that, where you can have chemicals that don't pass that framework or chemicals that pass it on a conditional basis or completely pass it. Then there's this really interesting development over the last few years that we're calling quantitative chemical screening and scoring. And a number of brands have taken the lead on this by generating a numeric score for a chemical or a formulation to really give clear guidance to suppliers and make it very objectively clear which formulation or which ingredient is better than another, even if they're in the same category of acceptable or preferred. And we'll get into some details on that when we talk about these 5 things. So the problem is that the conventional response, the compliance to regulations, really isn't working for stakeholders and businesses alike. Finished product testing has been the traditional strategy to make sure a particular material or formulation is compliant, and that's often too late in the process. When you discover a problem, you have a lot of changes to make or things to reverse out, including recall campaigns. Brands often incur too much risk under this model, and chemicals decisions really occur upstream. When you're testing downstream, you want to inform those chemicals decisions in a more effective way so that those problems don't occur with the finished product and downstream. So one of the things we do at Cyvera is we walk in the woods a lot, and we think about these potential solutions. So if you imagine you're sitting in the Shenandoah National Park, which is only about 20 miles from here in Charlottesville, and you're thinking about this problem, this challenge of how do we evolve the business process of chemical screening and chemicals management from one that is compliance against lists to actually selecting and understanding safer alternatives. One of the things that we've been developing over the last several years is an approach where you offer knowledge about chemicals, either individual chemicals or formulations, at every stage in the supply chain. So upstream chemicals management is the term that we're using for engaging manufacturers of products, their raw material suppliers, their chemical suppliers, and even sub-suppliers of formulations of chemicals or mixtures of chemicals or individual molecules, to help them see the difference in characteristics from a human and environmental health perspective at each stage where each of these decisions are made. Clearly communicating those expectations upstream to suppliers in an efficient way across thousands of participants in a supply chain is a very significant challenge. Enabling preferred selection of chemicals upstream will design out or reduce those chances of problematic chemicals making it into formulations and products and materials downstream. Saving money and reducing risk, of course, is the goal. Protecting supplier IP and meeting new requirements is a significant opportunity here. There's a lot of effort and interest in transparency, and the brands that we work with and our systems fully support that transparency. But we feel that transparency can be communicating characteristics and scores of chemicals without having to provide identities of ingredients and formulations between supplier and customer. And we found significant increases in participation in these programs when you can offer protection of intellectual property while still delivering assessment results downstream. So let's talk about the 5 things you can do to select safer chemicals. They are, and of course not limited to this, and very interested in feedback from the group on this list and suggested adjustments. Understanding the different types of chemical screening is a critical first step. There's a lot of work going on in the different approaches to chemical screening, whether that's reviewing restricted substance lists or getting into broader lists of chemicals and their characteristics, or getting further into full comprehensive hazard assessment. Those are different types of chemical screening. They each have different goals and different objectives, and it's important to understand those differences, and we'll get into that in a minute. Being able to understand a full formulation plus the impurities that come along with that is a critical step in selecting safer chemicals. If you're talking about selecting safer formulations, you need to understand the characteristics of all intentional ingredients in the formulation, plus the things that come along with it that aren't necessarily intentional, but they are a fact of dealing with formulations and chemicals in the supply chain. Impurities occur and exist, and managing those and understanding them is critical to safer chemical selection. So the list screening step is essential and critical and a very efficient first step in selecting safer chemicals, as Sally mentioned in the introduction. It's critical, but it's not the only step for selecting safer chemicals, and we'll talk about that in a minute. Comprehensive hazard assessment comes in several forms. We can talk about that a little bit and can answer any questions, but as you move past a list screen effort and you get into comprehensive hazard assessment, you'll see that it is a critical part of safer chemical selection, understanding a chemical from all of its human and environmental health characteristics where possible. And when data aren't available or an assessment isn't possible for part of those characteristics, that's still useful information to know that you're missing information about a chemical, and that might mean it's not an acceptable substitute. And then the advantages of scoring from a qualitative and quantitative perspective can give clarity to making decisions about one ingredient or another, or one formulation or another, and it really helps make more objective, especially for non-experts in toxicology and chemistry, where many of the decisions are made in selecting safer alternatives. So different screens, different goals. Basic compliance with regulations can mean just screening your products against, say, the Proposition 65 list of chemicals. Of course, there are more regulations than just Prop 65 if you're doing business in California, but that's an example of a compliance, regulatory compliance list of chemicals that you need to manage against. That will help you understand chemicals that are known to be problematic, but if a chemical is not on the Proposition 65 list, that does not mean it's a preferred or safer alternative just because it's not listed. And that's a really important distinction, and is the same distinction when you're talking about restricted substance list screening. So as you move up this ladder, screening against restricted substances is a very important first step to identify problematic chemicals. But chemicals that are not listed on restricted substance lists, it does not mean it's a safer substitute. And we'll get into some examples of that here in a minute. Now, one exception, or there are exceptions to the list screening step and selecting preferred alternatives. You all may be familiar with the US EPA Safer Choice Program and the safer chemical ingredient list that comes along with that program that's been very successful over the years and led by a very effective group of people at the US EPA. The safer chemical ingredient list is a list of chemicals that have preferred characteristics. So if you're selecting or exploring chemicals for a particular formulation, you can pull from the safer chemicals ingredient list and pretty much feel good about the characteristics of those chemicals that are on the skill collection of chemicals. So strongly encourage you to look into the skill part of the Safer Choice program at the US EPA. Risk-based certification, again, helps you understand if a formulation or a chemical is not on restricted substance lists, but it does not get into the full hazard, comprehensive hazard screening, hazard assessment. It provides for a certification against a list screen and a risk-based approach to chemical screening. Getting into the qualitative hazard assessment and quantitative chemical screening and scoring includes the comprehensive hazard screening, hazard assessment work that is so important to identifying safer alternatives in this day and age. And it's an important step to selecting safer alternatives. So getting to formulations and impurities, the work that we do and the work that we do with global brands includes a specific scope for what's included in the assessment. That scope is all intentional ingredients in a formulation and the impurities that come along with that formulation if the impurities concentration is greater than or equal to 100 ppm, 100 parts per million, which is equivalent to 0.01% in the formulation. So any impurity that is present in the finished formulation over or equal to 100 ppm is included in the assessment and needs to be scored as part of the formulation. Protecting supplier confidential information is critical in this process. So we work as a trusted third party, as do other service providers out there, to gather that information from the supply chain about the intentional ingredients and impurities in a formulation, evaluate all of those chemicals, ingredients, and impurities score them against lists and comprehensive hazard assessment, and then generate the results that go downstream to the customer and their customer, and sometimes on farther to the brand and the retailer, without revealing ingredient information. Once again, significant increases in participation from the supply chain when you offer that trusted third-party approach in your chemicals management and safer alternatives program. So the list is the first step. Just a short little case study here. We did a little work over the last couple of weeks in preparation for this webinar. Just for example, Proposition 65 list of chemicals known to cause cancer, that subset of the Prop 65 list of chemicals that are known to cause cancer. It's approximately 600 chemicals on that list of chemicals known to cause cancer to the state of California. In our work of doing comprehensive hazard assessment, we've identified over 6,000 chemicals used in consumer products and available on the market that are known to be carcinogens by our team of board certified toxicologists. So there's a 10x greater set of chemicals that have evidence and are known to be carcinogens than those on the CalProp 65 list of chemicals. So just screening against lists does not give you the confidence that the chemical you're selecting, if it's not on the list, it doesn't mean it's not a carcinogen. Doing that comprehensive hazard assessment and understanding those characteristics is critical. You can add additional lists and screen against more lists of known carcinogens and screen against lists of characteristics, but you still have significant gaps until you do that comprehensive hazard assessment by a toxicologist looking for all of the evidence available. Then even broader expansion of this set of chemicals, we found that over 40,000 chemicals in our knowledge base show some evidence of high hazard for carcinogenicity. Now that includes chemicals that have no available experimental or authoritative data about carcinogenicity, but our team has become very expert in computational toxicology, where we run modeling software to predict, based on the molecular structure of a chemical, predict the characteristics of a chemical with respect to carcinogenicity and 22 other human and environmental health endpoints. And that creates significant visibility into chemicals that are being considered as safer alternatives. Even though they're not on a list, you need that visibility of those characteristics. So comprehensive hazard assessment is just that. It gets into 23 human and environmental health endpoints. We look at regulatory lists and authoritative data as a first pass to understand those characteristics. There are increasing numbers of lists out there tracking chemicals for their characteristics, and that's a useful first step. But there's so much more work to do beyond that than just the list review. Looking at experimental data, interpreting the various data points that are out there for a chemical, that's the hard work of toxicology. Running those computational assessments, computational toxicology assessments, looking at modeled data and analogous data is another fundamental step that a board certified toxicologist takes to understand a chemical across those 23 human and environmental health endpoints. There are accepted frameworks out there for doing the comprehensive hazard assessment. The UN's GHS system, which originated in Europe and with the REACH program and has since expanded worldwide, the globally harmonized system for classification and labeling of chemicals is an excellent platform and resource for understanding these chemicals across these endpoints. The US EPA, as I mentioned, with their Safer Choice program, has a very established framework for evaluating comprehensive hazard assessment of chemicals across these 23 endpoints. As I noted, the Green Screen for Safer Chemicals is another great program that sets this comprehensive hazard assessment in place and moves to that qualitative work that I'll talk about in a minute for categorizing chemicals. And in our work here at Cyvera, we've established what we call a GHS plus framework for evaluating chemicals across these comprehensive hazard assessment characteristics for 23 human and environmental health endpoints. And that's the basis for which we do all of our work as a foundation, this GHS plus approach in our knowledge base of thousands of chemicals in our system. So the qualitative part of this, the qualitative step, is a very interesting opportunity for companies who are trying to identify safer alternatives. If you push 10,000 chemicals or even 1,000 chemicals through a qualitative screening program, whether that's GHS, green screen, safer choice, in general, what we've seen using our GHS plus approach, we've seen a normal distribution of chemicals across functional use groups. Let's say in this case study, solvents, and the solvents that we've identified through a database at the US EPA, we pushed those through comprehensive hazard assessment, and we found that around 200 of those chemicals come up with one or more concerns for an important endpoint: carcinogenicity, mutagenicity, reproductive toxicity, developmental toxicity, or on the environmental side, persistence, bioaccumulation, or aquatic toxicity. Those things are very important and flag high concern for a chemical based on available data. We've also found that the majority of the chemicals in that data set fall into that middle category where they have one or more concerns, but they're not that CMR PBT level of concern, and they might fall into an acceptable or conditional or okay group or category of chemicals. And then, of course, there are many chemicals, increasing chemicals through green chemistry work from a large number of chemical companies that are have preferred characteristics and low or moderate hazard only across all 23 endpoints. And that's an increasing area of opportunity. But you still end up with this ABC, 1, 2, 3, concern, okay, good categorization. And it's useful for the big buckets, but quite often the companies we work with need more feedback about which of the formulations or which of the chemicals in each of these categories are preferred within the category. And this gets to a quote we hear day in and day out. A lot of the companies we work with say, I just need a number. Just give me a number for this ingredient. I need feedback on whether this ingredient is better than that one from a comprehensive hazard perspective, or this formulation is better than that one from a comprehensive hazard perspective. And the work that we're doing with major brands, establishing this quantitative approach and helping them scale up the quantitative approach, is really changing the way suppliers and companies think about selecting safer alternatives. The quantitative approach complements the qualitative frameworks in that it provides more granularity, building on that foundation of the qualitative categorization of chemicals based on comprehensive hazard assessment. It results in a numeric score for individual chemicals and formulations, which enables easier comparative review of chemicals and formulations for selection of safer alternatives. Some examples that we are heavily engaged in these days are the Screen Chemistry program that was developed by Levi Strauss and Company and has since expanded to several fashion and active apparel and footwear retailers now engaged in the program. Nike Priority Chemistry is a quantitative scoring program that Nike has rolled out over the last 12 months or so, and you may have seen their chemistry playbook that they published in the last several months that gets into detail on the work that they're doing on priority chemistry, which includes a numeric score for individual chemicals and formulations. And we're also supporting this work with what we call a Cyvera Quantitative Chemistry Index, where based on that comprehensive hazard assessment, we're assigning a number to an individual chemical to help companies select a preferred chemical within a range of a category. So if you think about that graph from a few slides ago, there might be 300, 500, 1,000 chemicals in a particular functional use that fit into that OK area in a qualitative hazard assessment perspective. Trying to understand which of those 300 chemicals is preferred incorporates a number of factors, including availability of the ingredient, functional use and appropriateness in a particular formulation, but it also has a very important element of understanding the comparative hazard across those chemicals in that same category. We found that chemicals could score a 13 and be in that acceptable category or that OK category, and other chemicals also in that category could score 68 or 78 based on our quantitative system for comparing chemicals on an index. This can be very helpful for companies trying to find safer alternatives within the same category. Of course, you want to avoid and phase out the chemicals of concern that have been identified by either a list or a qualitative scoring framework. But once you start to get into the acceptable or the conditional and the preferred or the good categories, you want to always pick the best chemical or the preferred chemical that works for your formulation or your application with the most preferred characteristics, and assigning that additional quantitative number can be extremely useful. It's a heavy lift, but when it's automated in a system like Cyvera Lens Rapid Screen, it's right in front of you with the details that you need to dig into if needed. So these examples, Screen Chemistry, Nike Priority Chemistry, and Cyvera Quantitative Chemistry Index, we're going to get into great detail on these at the event next week for Safer Alternatives out in Sacramento. And I'd be happy to answer any questions about those today, but I want to make sure we leave plenty of time for questions and discussion afterward. So let's see. So we explored the 5 things over the course of the last 25, 30 minutes or so. We've looked at how safer alternatives require comprehensive hazard assessment, not just list checking, with the exception of preferred chemicals lists. And I want to encourage you all to join us at the Alternatives Assessment Symposium next week in Sacramento. And the last thing I need to do is put up the information about that. So if it's possible for you to make it and join this event, the agenda looks fantastic, and we're excited to see you there. Sally, that's all I've got. Yep, looking forward to questions and discussion. Thanks everyone for your time.
Thank you so much, Joe. And we do have some questions I'm going to be asking you, and if you have additional questions, please type them into the question box. So let me see what we have here. Let's start with this one. Does Cyvera, let's see if I understand this question. Does Cyvera certification conduct testing on final products after a chemical review of raw materials? I guess that's, I think the question is asking about if you're reviewing the chemical composition, do you conduct testing then later on the final product?
Yeah, good question. And I think there are 2 aspects of this. One, and we have this conversation very often with the brands and the suppliers we work with. Disclosure of a recipe to a trusted third party like Cyvera is a first step. So it's the intended or the expected ingredients in that formulation. In some cases, what actually ends up at the manufacturing facility might be different than that. And reconciling those 2 recipes, if you will, is an important step. Quite often, testing can help with that reconciliation. So if someone discloses the intentional ingredients and the impurities to a trusted third party like Cyvera, we generate a comprehensive hazard assessment and score for that formulation. One would hope that that same recipe is what shows up in the manufacturing facility. We, in some cases, work with brands and suppliers to do some audit testing of those formulations to put some teeth in the expectations of, if you disclose and declare that this is your ingredients and impurities in your formulation from a data point of view, you need to be sure that that's what shows up at your customer in a drum or in a material. So that often is part of the process. In most cases, the role we play is evaluating the data that's disclosed in the ingredients and impurities. We often work with test labs to audit that and test and sample the formulation that shows up at the customer to make sure that's an accurate declaration.
Okay, thank you. That's really helpful. And I have lots of questions here. So next one is, how do you balance performance with safer chemical selection? Materials and substances are often at the tier 2 or 3. So when you're back in the supply chain, in a sense, those are maybe two different questions. But how do you balance performance with safer chemical selection? And then when these materials are often back in tier 2 or 3 of the suppliers?
Yeah, it's I think the perennial challenge, and I think it's also the perennial pursuit of picking safer chemicals with safer characteristics that also perform like your customer, or even you as a product development professional, are trying to achieve. And from our point of view, we work in consumer electronics and that supply chain. We work in footwear and apparel. We work in household goods. We work in cosmetics. Our team of toxicologists, we're experts in evaluating the characteristics of chemicals and delivering that information in a cost-effective way. The experts that are making decisions about formulations, those engineers, those chemists, those specialists, they have to make the informed decision about whether a particular safer alternative, if that's what is being considered, will also perform for them and their quality requirements and for their customer. Our goal is to make access to the characteristics of chemicals, either through a qualitative or quantitative score, make access to those characteristics easier and more cost-effective to obtain. It's ultimately up to the product development people way upstream, developing the next formulation, or developing a raw material, or making a decision about which raw material goes into a shoe or a cell phone or whatever the finished product is going to be, and making sure that performance still meets requirements. It's a challenge, like it always has been, but what we try and do is provide that underlying human and environmental health characteristics in a very objective score based on the expectations of the brands we work with, to scale that upstream and provide that visibility quickly and cost effectively to the companies who need to make those decisions and find those safer alternatives. But it's like I said, the perennial challenge of matching that with performance and availability, for that matter.
Yeah. Well, thank you for that answer. And now there are a couple of questions related to the impurities. So let me read you. I think you can probably answer these together. So one is, asking about how did you settle on 100 part per million? Because disclosure, we know that for cleaning products in New York State, disclosure is required at much lower levels. Another question is what about impurities that are below 100 ppm but could be of a high hazard? So how would that affect the overall assessment or scoring of that chemical?
Yeah, great questions. And where the 100 ppm bumps up against a regulatory requirement for disclosing at a lower concentration, that regulatory requirement prevails. I think the 100 ppm level is, in most respects, just a practicality at this point. So engaging suppliers in their intentional ingredients and asking them to understand impurities at 100 ppm or higher is the first step for the brands that we're working with. I think ultimately that resolution will be more refined and go to 50 ppm or lower, but that's a ways off. Engaging suppliers for all intentional ingredients and impurities at 100 ppm and higher, with the exception of regulated chemicals, if that threshold is lower, is where the brands have set the bar at this point. And it's, I think, just for engagement and to keep things as practical as possible. As I'm sure all of you know who participate in this work on a daily basis, getting to 100 ppm of resolution for a formulation is often a huge challenge for a supplier and their sub-suppliers. So that bar is already pretty high, especially when it comes to consumer products that end up as articles. I think cleaning products and cosmetics, of course, is a different category and regulated in a different way. But most of the work we're doing these days is in articles and consumer products that are of more durable in nature, and that 100 ppm bar is where it's set, with the exception of a regulatory requirement when it's lower.
Thank you, Joe. And for those of you asking questions, keep them coming. There are a lot more good ones here. And if Joe has not answered the question that I have raised, please send a clarifying question if you have additional questions. So here's one about life cycle assessment. Does Cyvera have any plans to try incorporating life cycle aspects into the assessment process?
Yeah, that's a great question. We do indeed, and we collaborate with companies who are more focused on the LCA aspects of product development and materials consideration. We feel our role and our focus is helping to understand the underlying human and environmental health characteristics. We think there's been a significant gap in delivering that information in a cost-effective and scalable way for consumer product supply chains. So we stay very focused on delivering that comprehensive hazard assessment, qualitative and quantitative scoring for decision makers in the supply chain. Many have elected to, in a parallel way and in a complementary way, pursue circular economy initiatives, broader understanding of life cycle impacts of chemicals and materials, and we support that wherever we can. We have not integrated it into our software platform yet. We just try and complement where that work's already being done elsewhere.
So here's a complicated question and an important one. Can you explain about how you get to the quantitative number? What goes into that? How do you weigh different issues? It's very hard to compare at different endpoints, much less hazard and function in a way that people can agree on. And so I think that's a question, really good question, and it'd be important for you to comment on, where is expert judgment coming in? Where are you relying on science? How do you put that all together to come up with a quantitative number?
Yeah, great question. And the first answer to that is come to the event next week to get into the details. I'm co-presenting with my colleagues from Nike, Levi's, and the Zero Discharge of Hazardous Chemicals program based in Amsterdam. We're presenting in detail the approach to scoring in a quantitative way, the individual chemicals and formulations. But in short, and we didn't really have time to get into it today, in short, the foundation is the underlying comprehensive hazard assessment. And having characteristics of hazard across those 23 endpoints is the basis for moving into a quantitative step. That toxicology, assigning a low, moderate, high, or very high hazard for each of those 23 endpoints, that's fundamental toxicology that's based on GHS, that's common to the Safer Choice program, it's common to Green Screen, it's common to the GHS Plus framework that I mentioned that we implement in our knowledge base as a foundation to that work. Then, and what I'll get into next week with Nike and Levi's and ZDHC, is based on that hazard condition for each of those 23 endpoints, a score is assigned, a numeric score is assigned to each of those endpoints. And that numeric score is added across all 23 endpoints and divided by a total possible number, assuming, let's say, all 23 endpoints are low hazard for a chemical. That's the highest possible score you could get for that chemical. In most cases, you don't achieve that. I think maybe water is the exception right now. And so you have moderate, high, or very high hazard for certain endpoints. Assigning a numeric score to each of those conditions for each of those endpoints can give you overall a numeric score for that chemical. Higher scores are assigned to those, what we call core endpoints. So if you have low hazard for one of the core endpoints, CMR, PBT, you can achieve a higher score for your chemical. If you have high hazard for any of those core endpoints, it brings down the score substantially. And it also, as noted in the qualitative piece, triggers the chemical of concern qualitative bucket. What we're trying to do is help companies differentiate between chemicals that have moderate and low hazard for all endpoints and maybe high hazard for a few non-core endpoints, helping them differentiate ingredients and formulations and move up a curve of achievement towards safer formulations, safer ingredients based on that quantitative scheme. Screen chemistry and Nike priority chemistry build on that, and they ask a series of questions about list hits, yes or no, and then the comprehensive hazard assessment results within that scheme to generate that score. And my colleagues from Nike and Levi's are going to talk about that next week in detail.
So just one clarification on that, Joe. If it sounds like the core endpoints get a higher weight than some of the other 23 endpoints, and is that up to Cyvera makes that decision, or the client that you're working with would decide what the core endpoints are?
Well, the core endpoints are really pretty established in the GHS system and systems like Safer Choice, where carcinogenicity, mutagenicity, reproductive toxicity, and developmental toxicity on the human health side are the core endpoints, and persistence, bioaccumulation, and aquatic toxicity on the environmental and ecotox side. That's the approach that we've taken. Of course, those numbers can be adjusted, but the brands we're working with have supported that approach, and we're transparent about where those weights are established. If there's a need for a change and someone comes to us and says, we'd like the following additional endpoints to be weighted for that in that core category, we can easily support that in our software and scale that to however they need it. There's been really solid alignment because of the GHS system and its ubiquity across markets and categories, that those are the core endpoints and achieve that higher weight. And it's also consistent with the qualitative side of things, where if you have high hazard in any of those endpoints, it's going to trigger a chemical of concern in those conventional qualitative frameworks.
Okay, thank you. Here's a question. Do you consider exposure of these chemicals during use, or is your approach purely hazard-based?
Yeah, exposure is a very important consideration. What we are responding to with this quantitative approach is a focus on hazard and a focus on the characteristics for selecting safer alternatives. The brands that have come to us have long had a risk-oriented approach and have worked with their supply chains to manage and reduce risk as much as possible. When it comes to screen chemistry and Nike priority chemistry, the brands that we're working with in those areas are very clear that for purposes of selecting safer alternatives going forward, the focus is going to be that comprehensive hazard assessment and creating incentives to have companies move up that curve of screen chemistry and Nike priority chemistry scoring based on underlying hazard characteristics. I think ultimately companies want to manage their risk, and I think that the goal that they're implementing with this quantitative scoring is focused on hazard to simplify the process for future selection of future chemicals and formulations.
Okay, thank you. That's helpful. Here's a question about chemical mixtures, because most of the hazard data is for individual chemicals. So what work's been done in terms of looking at the hazard of mixtures, and how does Cyvera engage with that question?
Yeah, the scoring for screen chemistry and Nike chemistry incorporates the scoring at the formulation level incorporates the concentration of each ingredient and impurity and generates a weighted average score for the formulation based on the comprehensive hazard assessment of each ingredient. That being said, that score factors to a certain extent that mixture of chemicals based on that weighted average. In some cases, mixtures and their characteristics could be regulated based on the combined hazard characteristics for a chemical, say a solvent, and its toxicity according to the GHS system, and scoring according to mixtures and total toxicity from an acute perspective. The scoring schemes for screen chemistry, Nike chemistry, and Cyvera's quantitative index is based on individual chemicals and trying to improve formulations for individual chemicals and then that weighted average mixture. That was a long answer that kind of gets wrapped around both the regulatory side of mixtures and the scoring schemes. But we're trying to work with both approaches when we do this quantitative work.
Is any of your numeric scoring publicly available?
Yeah, so as of next week, when we roll out this detailed explanation, we're going to be publishing the details of the quantitative scoring for the Cyvera index that I mentioned on an individual chemical basis, and then you're going to increasingly be seeing information about the screen chemistry program and Nike priority chemistry and how those are similar and the specifics of scoring for each over time.
And that would be available, so you'll be sharing that, and then how would it be available?
So we'll be sharing the details next week at the event, and then getting into availability of the details on Cyvera's website and places where the screen chemistry and Nike priority chemistry programs are being distributed in detail for transparency about how chemicals are scored.
Great. Well, I've gotten through most of our questions. It's 1 o'clock. I think I have one more slide here where I wanted to just let our participants know that to put on your calendars, I know this is far away, but put it on your calendar now, our annual GC3 Innovators Roundtable will be May 7th through 9th, 2019, Cincinnati, Ohio, hosted by Procter & Gamble Fabric Care. And we hope that many of our members, as well as those who are interested and want to get to know the GC3, will come to that event. Pencil that in. And I want to say a really great thank you to you, Joe. I think this has been a really informative webinar. You've provided a lot of food for thought and information about the work that Cyvera does to support really informed decision making about safer chemicals and products. So I really want to thank you.
Thank you, Sally.
So thank you, everyone, for participating. And we will, I believe, we recorded the webinar, and the slides and recording will be available on our site. So thank you so much. And here's information. Here's our website if you want more information about the GC3. Thanks, everyone.